Hello. Today we are going to discuss the log normal distribution. By Benford's law, most of the things in the world start with 1. That's because most of them are log normal distribution. On the other word, log normal distribution describes the world. So, we want to find the expectation of the log normal distribution function. First, we consider the Gaussian integration.
Okay, so the Gaussian integral from negative infinity to infinity, e to the power of the negative x squared. It can if we try to calculate its indefinite integral, we can use elementary function to express it. So, but we can know how to calculate its definite integral. So, but it is improper integral, so we need to use another solution to calculate it. First, let I of a equals to integral negative a to a e to the power of the negative x squared, and we take limit to get the Gaussian integral. Now we want to calculate I squared equals to this obtuse. So by Fubini's theorem, we know that it is double integral r e to the power of negative x squared plus y squared dA. And the r is just like the square we draw. You can see it is the square. And now, how do we calculate the I squared? You can see the picture. The circumscribed circle is bigger than the r, which is the square. And the square is bigger than the inscribed circle. So we can also use polar coordinate to get this inequality. So and now we get a value to this pi product 1 minus e to the power of negative a squared less than I squared, less than pi product e minus e to the power of negative 2a squared. And now by squeeze law, we take limit, and the value is equal to pi. So the I squared take limits equals to the Gaussian integral square equals to pi. So we know that the Gaussian integral equals to the root of pi. We don't care about negatives because e to the power of x are always bigger than 0 for all x are real number. Okay, so now we know the Gaussian integral's value.
Now, we are going to use it to prove if x follows a log normal distribution with parameters mu and sigma squared. Then we expected value of x is equal to e raised to the power of mu plus 1/2 sigma squared. First, x follows a log normal distribution if the natural logarithm of x is normally distributed. That is, log of x is distributed normally with mean mu and variance sigma squared. The probability density function of a log normal variable x is f of x equals 1 divided by x times sigma times square root of 2 pi. multiplied by exponential of negative open parenthesis log x minus mu squared divided by 2 sigma squared closed parenthesis for x greater than 0. By definition, the expected value of x is the integral from 0 to infinity of x times f of x with respect to x. Substituting the density function, we get the integral from 0 to infinity of x times 1 over x sigma squared root of 2 pi times exponential of negative log x minus mu squared over 2 sigma squared with respect to x. Now we cancel x in the numerator and denominator. This simplifies to the integral from 0 to infinity of 1 over sigma squared root of 2 pi times exponential of negative log x minus mu squared over 2 sigma squared with respect to x. Let's simplify the expression with the substitution. We let y equals log x and dx equals e to the power of y dy. Then we get x. We have the limits change from x equals 0 to infinity to y equals negative infinity to infinity. Substituting, the expected value becomes the integral from negative infinity to infinity of 1 over sigma squared root of 2 pi times exponential of negative 1 minus 2 pi 1 minus mu squared over 2 sigma squared times e to the y with respect to y. We now combine the two exponential terms. Exponential of y minus mu squared over 2 sigma squared. So the expected value becomes the integral from negative infinity to infinity of 1 over sigma squared to root 2 of 2 pi times exponential of y minus mu squared over 2 sigma squared with respect to y. Simplify the exponent. We want to write y minus mu squared over 2 sigma squared as perfect square of form. So we let t squared equals square of y minus mu minus sigma squared over 2 sigma squared. Then we have this integration. Therefore, its expected value of x equals e to the power of mu plus 1 of 1/2 sigma squared. So if x follows a log normal distribution with parameters mu and sigma squared, then the expected value of x is e raised to the power of mu plus 1/2 sigma squared.